So we're going to jump in here with percentages, markups, markdowns today. Even though we're kind of recording this, we go, feel free absolutely to pop questions at me as we go, just to make sure that we're on the up and up with things. So I'm going to do a little change of order on what we've got on this first page. I'm going to actually start at the percent change, work down, and come back up. So stick with me here. I am not skipping over stuff. I'm just changing the order around a little bit. So first thing to discuss here is a percentage of change. Now, that is one of the things from that video lesson that we'll see if we can get a little more of a descriptor into for here. So, describes how much a quantity has changed relative to its original or its starting amount. Yeah, we're just on the first page of that new packet that we got hold of here. So if you did get through some of the video before, you may have some of this down already, but it never hurts to catch something in extra time. So a percentage of change can be a positive or a negative thing depending on what it is we're talking about and whether it's an increase or a decrease. The way we calculate it is going to be similar. Oh, now I have not seen another computer unless it happens to be on a table or unless Coach grabbed it. I don't see one there, and there's none back over here. So the amount is going to be the difference between the original and new value. So whether it's an increase or a decrease, we're really not going to know until we're a little ways in. But it's a two-step process that we're going to do every time with this. So the first part is we're going to subtract the original and the new prices. Now, it's not necessarily going to be in that order, because when we do this, we want to do the bigger minus the smaller. We don't want to end up with negative numbers here. So when we go to subtract those, and we'll get an example up here in a sec too, that's the route we're going to go. And then once we have that answer, we're going to divide the answer in the first part by the original price. And like I said, we're going to do a numeric example here so you can see in a minute, so we can make sure that we're following things okay. So let me get creative here on the fly, and we can kind of see. Actually, let me peek one thing ahead. Perfect. That's even better. Okay, so for example on this one, and I'll put this back up in just a sec. For example, if we were on that percentage of change practice, okay, on the following page. So find the percentage change and see if it's an increase or a decrease. Okay, from 45, this is my original height, to 92. Okay, that's going to be my new height. Subtract original and new prices. Okay, so step one. We're always going to take bigger minus smaller because we don't want a negative. So we'll do that first. Once we have that, then we're going to divide the answer from number one. So we're going to take that 47, and we're going to divide it by the original. So we're going to take our answer from part one, 47, and divide it by the original height. Let's see what we get here. So 47 divided by 45, we'll just go to a couple of decimal places here. So 1.04, but we want it to be a percentage. So we're either going to move the decimal point right 2 places, or if we want to use the calculator, we'll just multiply by 100. So 104, we'll just go to 104.4%. That's a large increase. And here's how we tell the increase-decrease part, because I haven't put that on the other page yet. We will in a moment. If the number got bigger from the original to the new, it went from 45 to 92, it got bigger, that's going to be an increase. That's how we play the increase-decrease game. If the smaller number would have been second, we would have called it a decrease. The math would not have changed, though. And so what we probably want to put back here in the example area, so we'll kind of split that off. And then we'll be like, if the new number is the bigger one, like it was in this case, that's an increase. When the new number is smaller, that's a decrease. And we'll find an example of one of those on the next page too, just to make sure that we've got ourselves in a good place. But like I said, no matter what goes on with that new number, the math, those 2 steps, will not change when we're looking for a percentage change. And you're going to find that pattern kind of rolls with a lot of the things that we do. So, for instance, let's say we had number 5 down here. From 94 to 34. Okay, we started at 94. Now we're at 34, old to new. Do 94 minus 34. And then there's my answer to number 1. So that's what I'm going to start my second step with. And we always divide by the original number. Whoop. Would help if I put the right numbers in, though. Even if you went to 0.64 here, that would be fine. No biggie. And then just move that decimal place over. But since the new number is smaller, it got smaller, it shrunk, it decreased in distance in this case. So those are the 2 options that you can get to on these. Same steps, just a different word that we're going to be using on the end. Okay. So let's see here. So that kind of gets us set back here on 3 and kind of where the lesson was going for the main part last time we met. But I kind of want to stay in this area. So I want to play with this markup, markdown, which you're going to see is kind of similar in some ways. So when you're a business, you're hoping most of the things you're having you're going to mark up. It means you're making more money on it. So this is the amount of increase from the cost of an item to its selling price. Like, if I'm going to sell something in a store, I'm going to buy it for a certain amount, and I'm going to raise it a certain percentage, and I'm going to sell it to you. Kind of the middleman, I guess you could say, unless I'm making it myself originally. And so that markup percent increase is what we call the markup percentage. So here's how this works. Split this little box down the middle here. We're going to do markup on half, mark down on the other, so we can tell the difference here. So when I'm going to mark something up in price, it's the price plus the markup. So let's say, for instance, I'm Best Buy, and I have a certain phone that comes in that its original price to me is $900. So we look to see, sometimes manufacturers will give us a markup, sometimes we got to figure it out ourselves. But let's decide we're going to do a 20% markup. So here's how this works. Another two-step process, slightly different from the last one we did. And basically what you're going to do is you're going to take the price times the percentage as a decimal. So remember, if we're doing that, we're dividing the percentage by 100. So we'd multiply by 0.2 or 0.20. And so the actual markup would be $180. Now that doesn't mean I'm selling it, of course, for $180. That's just how much extra I'm going to place on it. To show you the retail price or the selling price, and this markup can be different for any business you have. Like there are some businesses where the markup is very small, where you sell a lot. Grocery stores typically have a very small markup on their prices, a small margin. But there's other places like restaurants where the markup can be huge. It can be 200% and 300% of what they pay for things. And that comes into some different things, which we'll discuss too as we move on. But for now, it's just those two steps. And that would be how our markup works. Markdown, kind of like this increase-decrease was up here. Markdown, maybe something's not selling or you just want to get it out of your stock. So that's a decrease from the original price of an item. You could almost call this at sale price. If you've ever seen sales and things, those are markdowns. Sometimes they're called discounts. And so that can also be written as a percentage. But once again, what's going to be important here is that it's going to be the same two steps again with one difference. And you probably can already figure out what that one difference would be. And that would be, it's going to be that original price minus the markdown. So instead of adding it, making it more, we're subtracting it and making it less. So, for example, let's say we're at Kohl's or somewhere and there's some jeans that are going out of season. So we got us an $80 pair of jeans, normal price. And since, we're getting ready for spring and shorts are coming out, we need to clear up some things. We're going to give everybody a 35% mark down discount. The only difference when we get to the two math steps is going to be the sign in the middle when we're to the end here. So, $80 pair of jeans, 35 divided by 100, to get our 35%. I almost wrote discount. I guess that wouldn't have been terrible. So our jeans are going to be marked down $28. So we just subtract that from the 80 and find out what that new markdown, sale, discounted price is going to be. So we kind of see with both of these, lots of words. Okay, lots of wordiness, but when it comes down to it, it's just 2 steps on each of them to get the numbers that we need. So I don't go too crazy since we kind of combine the 2 lessons here. There's only one other thing I want to do. I'm going to go down to the bottom here with our percentage of error, and then we'll kind of start to wrap here. So percentage of error. This is a little more interesting in business. This is useful for determining the accuracy of your calculations. Maybe sometime you want to know how much something is selling and you kind of guess what it is. You estimate instead of actually going to the numbers because it takes too much time. Your person in charge of that's not working today, whatever it happens to be. So, what we're going to talk about, now I'm going to change some vocabulary here a little bit. Mathematically speaking, the experimental value, I'll use their terms and then we'll use our own, is your observed value. What's actually, going on, what you're kind of guessing. I'll put the word guess in there. And the theoretical value is your actual value. So let's speak in terms that are probably going to be easier for us to kind of go along with here. We're looking more at another 2-step thing, which we'll put easier verbiage into here. When we want percent error, once again, we're going to subtract the 2 values, kind of like we did in percent change. Once we have that, okay, we're going to take that answer from number 1, divide it by the actual value, and then multiply it by 100 to get back into a percentage. Now again, when we're just talking in words, that can absolutely be confusing, and I get that. So again, I want to jump into one of the practice ones, or a couple of them, and just kind of see, okay, what does this mean? And maybe we got to change some wording around here a little bit. So we're going to go forward here, okay, over to page 5. That's where the percent error worksheet part is. And so, for instance, might as well start at number 1. Jessie estimates the weight of her cat to be 10 pounds. Okay, so she's estimating, this is our guess. We guess the cat is 10 pounds. The actual weight of the cat is 13.75, and they even use the word actual, which I appreciate. Okay, find the percent error. So with what we had back here, it said first we got to subtract the 2 values. We never want to have a negative with this either. So we're going to subtract the 2 numbers, bigger minus smaller, and get that first answer, 3.75. That's the difference in pounds between the guess and what reality was. So now for step 2, we're going to take the answer from number 1 and divide by the actual value. Whether that's the bigger number or smaller, we don't care. We divide by the actual. So I'm going to bust out my calculator. You can do these separately or you can do them all at once. You can do 3.75 divided by 13.75 in parentheses and times by 100 if you want to do it all at once. And we'll go to 1 decimal point. If I do it all at once, I get the actual number. If I do it in parts, okay, there's the decimal part, and I multiply by 100, I get the same thing. But that's what we're looking for. We're not looking for an increase, decrease, just how far off, was I from what reality is. So, I mean, one more just to play, just kind of make sure. Big minus small. Okay, Mr. Jones thought he was going to spend 120. He actually spent 94. That's a nice error. The only thing we're really going to have to think about is, okay, what was he actually spent 94? So that's the number we're going to divide by. So you'll notice the first time the bigger number was the actual. This time the smaller number was. It can vary. So 27.7 if we wanted to round there. Okay, and we've got that. So let's do this. I'm trying to think ahead a little bit. So let's do this as far as practice goes. So since we'd already done a couple over here, and if you did the others that I'd said before, well, you can stick with those two if you want to go. So we'll just put it this way. We'll say we're going to go odds or evens here. You're like, well, Hardy, you already did 2 of the odds. True. So I'd probably just keep doing odds. But if you start to do the evens, that's okay too. I'll have answers for all of them. So either one there on 3. 5, there's only a few left I'm not worried about. And here's all I want you to do on 4, because we're going to have more work time tomorrow too, besides the 20 minutes now, because tomorrow's will not take as long. So here on this page, again, I would say take your pick. I would, yeah, it's not going to make any difference. Okay, so if we just ran the evens, so basically the right side of the page here, okay, just so we don't get confused on language, markup, markup, add it, add it, add it, discount and mark down are the same thing. Markups, you're adding the extra. Markdowns or discounts, you're subtracting, just like we did when we were writing them in the practice over on the other side. Okay. Again, it just gets you some play with all of these, so you can start getting used to the language that we're doing, especially when words tend to change right in the middle. Discount and markdown, and kind of works from there.